One of the more difficult things to discuss, especially with the short time that we have, is discussing the topic of individual communication protocols. It's easy enough to say, well, if you have all the right networking components, your system will work. But let's talk a little bit about one of the older standards, but also one of the still very prevalent standards in industrial automation, and that is RS-485. Now, RS stands for Registered Standard, and 485 is the connotation that's different from RS-232. And let's contrast the two a little bit. RS-232 is a very common serial protocol called point-to-point, which means it's very good at establishing high-speed data between one device and another terminal device. So we might see it as a communication protocol for, say, downloading a program to a PLC. RS-485, on the other hand, while it does transmit data, is a multi-drop type of system, which means that using positive and negative supply and a positive and negative communication supply, like a positive-negative voltage for a signal, can be attached across many devices. Now, one of the things that changes when you have a point-to-point interface versus a multi-drop interface, sort of like how we can think of Ethernet, is that since there's a lot of devices, the communication protocol needs to know which device it's talking to, which means addresses are important. In RS-485, we refer to these as nodes. These nodes will have addresses. For each specific variation of RS-485, the standard will determine how many nodes are available for each system. What we can do with these ones is send over communication protocols such as Modbus. That's a very common one to be used over RS-485. We can read and write individual coils. We can read and write contacts. We can also send registers, which are variable numbers, like analog information. The RS-485 protocol uses twisted pair wires, which means that it can last over a long distance. That's a distinct advantage over those point-to-point interfaces. Now, there's so many different types of networks, network protocols, and end connectors that we see this showing up in a lot of different formats. RS-485 does not refer to the style of the plug, because here we can see an RS-485 that's a 4-pin connector. Here we can see it as an RJ11, which is a 6-pin connector that looks strikingly like an Ethernet, but a little bit smaller. And here we can see it as individual screw terminals. Each ones are labeled and we can find the pinouts for those, but the RS-485 standard determines voltage signals and voltage levels and speeds and distances that we can configure a network protocol to ride on top of, such as Modbus, to allow the right kind of data to be traveling over that RS-485 standard and give us a reliable network across our entire facility.